We are going back to the moon. Why aren't more people talking about this? Welcome back to Space According to Skylar. I'm Skylar, I'm an astrophysics PhD student, and today we are going to talk about the Artemis program, specifically Artemis 1. Because the Artemis program is taking people back to the moon, and that process starts in exactly 1 week. On August 29th, knock on wood, because these launches tend to get moved around a lot, but in theory, 1 week from today, the SLS rocket, seen here, is going to launch, starting off the whole Artemis program. This first mission, dubbed Artemis 1, is an uncrewed mission to test the rocket and the spacecraft, and also do a few other sciencey things along the way. And for some reason, not a lot of people know about this. Because after this comes Artemis 2, which will have people, and they will go in orbit around the moon. Artemis 3 will land people on the moon, and then in the future, we're going to build a lunar base and a space station in orbit around the moon that could one day help humanity get to Mars. It's a really big deal, and it all starts next week. So in honor of that, I just want to give a brief little overview of Artemis 1, what its goals are, how long it's going to take, what it's going to do, and then what comes next. Also, if you don't know, I will actually be in Florida for this launch. I got accepted to the NASA Social, so I'm going to be at a multiple-day event where I'm going to see a bunch of facilities, talk to experts, and then actually see the rocket launch. So there will be tons of content coming out about that. Although since the rocket launches next Monday, there will not be a video next Monday. With all that being said, let's get started. And I'm going to start with a question that I get a lot. Why now? The Apollo missions were more than 50 years ago. Why has it taken us so long to get people back to the moon? And why did we have to build a whole new rocket? Well, the answer to that is multifaceted. The first issue is during the Apollo era, everything was super rushed. They just wanted to get to the moon first. And so because of that, nothing was really built or designed for reuse. There is almost no documentation about the actual rocket used, the orbiters. All of the infrastructure needed to get the thing built was scrapped after the end of the Apollo missions. So there's pretty much nothing that we could use to build off of. The second thing is money. We were able to get to the moon in the 60s because there was a giant government push to get us there. NASA received a record high 4% of the national budget. Today, they're getting less than 0.5%. Without the international pressure and competition, there hasn't been as many resources funneled into NASA to allow this to happen. So it took a little longer. Also, the ultimate goal of the Artemis missions is a sustainable presence on the moon. Apollo was just, get people up there, we're done. But Artemis wants to build a lunar base and a lunar space station so that humanity can go up there kind of frequently. So that makes things a lot more complicated. There's a lot more engineering that goes into building a lunar space station than it does getting somebody to step onto the moon and then back to Earth. So that's why it's taken so long. But it's still really exciting that it's happening. So let's talk about what's actually going to go on with this first mission. All right, Atlas, tell the people about Artemis 1. What's going on? He's very excited. So the primary objective of Artemis 1 is to test the systems. Let's make sure before we put humans on these things that the SLS rocket can get into space, that the Orion spacecraft can go along its orbit as designated, and that it can safely return and crash down in the ocean. So the steps of this mission kind of go as follows. Step 1, launch the rocket. Rocket gets launched into space, everything detaches from everything else, the rocket boosters fall away, and the spacecraft, called Orion, gets propelled towards the moon. As Orion is traveling towards the moon, these little tiny satellites called Cubesats are going to be launched to do a bunch of interesting science, and we'll talk about those more later. But Orion, a spacecraft designed to hold 4 humans, is going to continue to travel 280,000 miles away from the Earth. That's further than any spacecraft designed for humans has ever gotten. So Orion will pass about 60 miles above the surface of the moon and then continue on a very highly elliptical orbit, taking it pretty far away from the moon. It will stay in that orbit for about 6 days before it returns to the Earth and crashes down at a predetermined location in the Pacific Ocean. They want to be sure we can actually keep the trajectory of the spacecraft in line, that we can return it safely to Earth, and that we can get it up there in the first place. Of all of those steps, getting it up there is probably the most difficult, and that is why we have the SLS, the Space Launch System, or the rockets that are going to be used by all of the Artemis missions. This is the most powerful rocket in the world. It can provide 15% more thrust than the Saturn V, which is what was used in the Apollo era. By the time Orion detaches, it will be going over 24,000 miles per hour thanks to the boost from this thing. Now, although I'm an astrophysicist, I'm no rocket scientist, so I'm not going to try to explain how a rocket like this actually works. I will say that the fuel is liquid hydrogen and liquid oxygen, which has to be kept pretty cold, so this orange color that you see is actually an insulating foam that they spray over the entire core stage. While I said the SLS will be used for the whole Artemis mission, it's going to be evolved. This rocket came from a combination of new design and utilizing things from like the space shuttle, and it's going to change as we change what sort of things we want to get into space. Here you can see a kind of predictive evolution of this rocket over the course of the Artemis missions. Fun fact, this whole structure, taller than the Statue of Liberty. It's pretty amazing. Now, since we're going through the effort of getting stuff out into space, we want to make sure a little bit of science happens too. To accomplish that, we are using these things called Cubesats, which are really tiny satellites, about the size of a cereal box. In the kind of intermediate area between the rocket and the Orion capsule, they have a space where you can attach a bunch of Cubesats, and with Artemis 1, there are 10 that are going up. They are going to be released after Orion detaches, and they'll be sent off in all sorts of different directions. Here's a brief overview of the type of science each of these Cubesats is going to do. 2 of them are hunting for water on the moon. One of those 2 is actually designed by ASU professors, and as you may know, I'm an ASU student, so yay! Go Sun Devils. Is that? I think it's this. These satellites are hunting for water and then also mapping out where the ice is on the moon. We care about this because in the future, when we are, for example, determining landing spots for the Artemis 3 mission, we want to land somewhere where we can do interesting science. And there's a lot of interesting science that can be done with lunar ice. So it's good to get a good idea of where it is. A couple other moon-focused Cubesats include one that is going to try to figure out how we could get a small lander onto the surface, and another one that's going to fly by and take infrared images of the moon's surface. Another one is testing plasma thrusters in a kind of drag race to the moon, while yet another Cubesat is just monitoring how the SLS performs. One of them is going to try to fly to a nearby small asteroid using a solar sail. Yet another one is taking up a bunch of yeast to try to study the impacts of interplanetary radiation on life. The last 2 are more space weather focused, one of them studying Earth's plasmasphere and another one studying the weather that comes from solar winds and solar flares. So that's a lot of science that is coming from this mission. Whew. So all of this is supposed to happen starting August 29th. The entire mission is going to last about 4 weeks. There's lots of uncertainty in here because things depend on the relative positioning of the Earth and the Moon, where the actual spacecraft is in its orbit when it's time to come home, stuff like that. Like I said, I will actually be at the Kennedy Space Center when this thing is launched, so be excited for a lot of upcoming content delving more into detail about this program and sharing my experiences. As always, if you liked this video, please give it a thumbs up, leave a comment, subscribe, ring that bell, do all the YouTube things, and I can't wait to share more with you about Artemis 1.